The James Webb Space Telescope has made a groundbreaking discovery: beams of light that seem to radiate from what resembles an urban center, located light years away. This extraordinary find has reignited the age-old question: are we alone in the universe? When the telescope focused its attention on Proxima Centauri b, an exoplanet orbiting our nearest stellar neighbor, it detected strange, bright flashes of light. Could these be signals from an alien civilization? For decades, the idea of extraterrestrial life has fascinated both scientists and the public. Every hint of life beyond Earth has sparked excitement and speculation, but the evidence uncovered by the James Webb Space Telescope marks a potentially pivotal moment. While surveying deep space, the telescope picked up unusual lights on a distant planet, lights that bear a striking resemblance to those from cities. This has fueled speculation that a technologically advanced alien society may exist on Proxima Centauri b. The scientific community is buzzing with curiosity and anticipation. Could this be the breakthrough they've been waiting for? The lights appear city-like, even from over 4 light-years away. NASA engineers are now wondering how long these signals may have been shining, undetected until our technology reached a point where it could observe them. David Kipping, an astronomer at Columbia University, describes this exoplanet as unusually complex. Unlike typical rocky planets that absorb sunlight and re-emit it as infrared radiation, Proxima Centauri b behaves differently due to its unique interaction with its star, Proxima Centauri. The Webb telescope's ability to observe in infrared wavelengths played a critical role in identifying these anomalies. Researchers plan to continue their investigation, analyzing the planet's atmosphere in more detail to assess its potential for habitability. The telescope's sensitivity to faint infrared light allows it to observe Proxima Centauri b even on its night side, something most telescopes struggle to do. This capability may help confirm whether the mysterious lights are artificial and possibly from an advanced civilization. Importantly, the Webb telescope can detect artificial light. It falls within a specific frequency range narrower than that of natural starlight. Proxima Centauri b's dynamic interaction with its star significantly affects its environment. Like Earth, it experiences cycles of day and night, with extreme temperatures if no atmosphere is present, scorching during the day and freezing at night. These temperature variations are key to understanding the planet's atmospheric conditions. The James Webb Space Telescope, with its ability to capture thermal emissions in the infrared spectrum, is an essential tool in this analysis. Interestingly, its orbital timing aligns with the 11.2 Earth-day orbit of Proxima Centauri b, giving scientists a unique opportunity to monitor the planet's full day-night cycle. If the planet does possess an atmosphere, the next phase will involve analyzing its chemical composition to determine whether it might support life. Researchers are especially looking for key biosignature elements, like oxygen, methane, and carbon dioxide, that could hint at biological activity. The presence of gases like oxygen, water vapor, and methane in a planet's atmosphere could indicate its potential to support life. Detecting these elements involves analyzing the light that passes through the planet's atmosphere, a complex and challenging task. While the James Webb Space Telescope JWST excels at studying planetary atmospheres, it was not specifically designed for this purpose. Its strengths lie in identifying the presence of water vapor, carbon dioxide, and methane. However, it is less capable of detecting free oxygen, which is one of the strongest indicators of biological activity. Still, the JWST can search for other important markers, such as ozone, which also hints at a healthy and life-supporting environment. As scientists examine the data collected by the JWST, the ongoing search for distant, potentially habitable worlds continues to bring us closer to answering the age-old question: are we alone in the universe? It's worth noting that JWST can observe only a limited number of nearby exoplanets. For more in-depth analysis of exoplanetary atmospheres, astronomers are turning to future ground-based telescopes, such as the Extremely Large Telescope, ELT, expected to begin operations in 2028. The ELT will offer a more detailed view of exoplanet atmospheres, allowing researchers to gather higher-resolution data and gain deeper insights into potential habitability of these distant worlds. While the scientific community eagerly awaits the ELT and other next-generation observatories, the JWST remains an essential instrument in the exploration of exoplanets. Despite its limitations, it continues to provide valuable data that could transform our understanding of the universe and the possibility of life beyond Earth. Looking ahead, researchers have bold plans for space telescopes equipped with advanced technology that can reduce interference from starlight, one of the biggest obstacles in observing exoplanets. Much like shielding your eyes from the sun to see more clearly, these new telescopes will use innovative methods to block out the overwhelming glare of stars and capture the faint light reflected by surrounding planets. This will make it significantly easier to study their atmospheres and determine whether they could sustain life. However, this task is far from easy. Stars shine with incredible brightness, often outshining the dim light reflected by the planets orbiting them. To overcome this, scientists are developing sophisticated techniques like coronagraphs, devices inside telescopes that block starlight while allowing the planet's light to pass through. By shaping the light waves precisely, coronagraphs can reduce stellar glare and reveal the subtle glow of distant exoplanets. Another promising innovation is the Star Shade, a large, flower-shaped spacecraft that flies in formation with a telescope positioned tens of thousands of kilometers away. The star shade blocks the starlight before it even reaches a telescope, allowing only the planet's light to be observed. This approach could be particularly useful for detecting planets in the habitable zone, where conditions might allow liquid water and potentially life to exist. These technologies demand exceptional accuracy. For example, aligning a star shade with a telescope must be accurate to within a fraction of a millimeter over vast distances. Additionally, these tools must be compact, energy efficient, and durable enough to function in the harsh conditions of space. Despite these challenges, the potential scientific rewards are immense. Successfully analyzing the atmospheres of exoplanets could lead to the discovery of biosignatures, chemical traces like oxygen, methane, or water vapor in specific ratios that may indicate biological processes. Scientists are also working on ways to directly image exoplanets in greater detail. Future telescopes will likely incorporate adaptive optics, which adjust for distortions caused by Earth's atmosphere or the telescope's own movements, delivering sharper, clearer images. When combined with light-blocking technologies, these advancements could finally allow us to see and study distant worlds like never before. Advancements in space technology are opening new frontiers, not only enabling scientists to detect exoplanets, but also allowing them to map planetary surfaces and investigate alien climates in detail. The emergence of next-generation space telescopes marks a major leap forward in humanity's quest to answer one of its oldest and most profound questions. Are we alone in the universe? With each breakthrough, we move closer to discovering whether life exists beyond Earth, an outcome that could fundamentally transform our understanding of our place in the cosmos. Space exploration is accelerating at an unprecedented rate. As scientists delve deeper into the mysteries of distant worlds, the James Webb Space Telescope JWST is ushering in a new era of discovery. Its powerful instruments are helping astronomers uncover groundbreaking information about the structure, composition, and potential habitability of exoplanets. Every data point brings us a step closer to answering the ultimate question of whether extraterrestrial life truly exists. The discovery of Proxima Centauri b, a planet orbiting the closest star to our solar system, represents just the beginning of what may become a revolutionary phase in the study of alien life. Though Proxima Centauri has long fascinated researchers, definitive evidence, such as signs of artificial light or technological activity, remain elusive. Now, early observations from the Webb telescope suggesting unusual light patterns have reignited hopes that intelligent life may one day be detected. This kind of discovery not only fuels scientific curiosity, but also captures the public imagination, inspiring new generations to look beyond Earth. JWST isn't just scanning for artificial illumination, it's also analyzing atmospheric chemistry, searching for biosignatures like methane or carbon dioxide in specific concentrations. Such elements are critical clues for assessing a planet's ability to support life. What sets JWST apart is its unmatched capability to detect and analyze the atmospheres of distant worlds. This allows astronomers to assess whether the chemical environments on these exoplanets resemble those that sustain life on Earth. One of the most intriguing aspects of Proxima Centauri b is its location in the habitable zone, the region around a star where conditions might be just right for liquid water to exist, which is essential for life as we know it. Discovering planets in this Goldilocks zone is a top priority for future missions. But identifying potentially habitable planets isn't just about water. It also involves understanding how these worlds interact with their stars. Some, like Proxima Centauri b, may be tidally locked, meaning one side always faces a star while the other remains in perpetual darkness. This could result in extreme temperature differences and dramatically affect climate conditions and habitability. Technological innovation is playing a vital role in overcoming observational challenges. For instance, coronagraphs and starshade technologies are designed to block out the intense glare of stars, making it possible to observe the faint light reflected from orbiting planets. This capability is crucial for studying surface conditions, climates, and even signs of life. Another thrilling development is the push for direct imaging of exoplanets. With advances in adaptive optics and light-blocking techniques, astronomers are aiming to capture high-resolution images of these distant worlds. Such images could reveal surface features like oceans, continents, or weather systems, offering a more detailed understanding of what these planets are truly like. This leap forward in exoplanet imaging will significantly enhance our ability to assess their potential to harbor life. The James Webb Space Telescope and future missions will be indispensable in this journey. By detecting faint signals from across the galaxy, analyzing atmospheric components, and identifying signs of habitability, these missions are redefining our grasp of the universe. With rapid technological progress and an ever-growing stream of discoveries, we stand on the brink of revelations that could forever alter our view of life beyond Earth.